All right, so I'm going to try to explain how to figure out the payment amount on a loan that you take out. So we're going to look at a $600 loan that needs to be paid back in 6 months, okay, at a 12% annual rate. All right, and so some information you're going to need is number of payments left, okay, number of payments made. Okay, those are just going to go work with each other. So we'll do that first. So, right, originally you're going to have 6 payments. Okay, and then 5 and so on. The nice thing about spreadsheets here is you can, if once you get a pattern going, it recognizes the pattern for you. Right, we're gonna go all the way down until we have 0 payments left. Right, and then we're gonna start. If we have 6 payments left, we've made 0. Right, if we have 5 payments left, we've made 1, and so on. So again, I'll recognize the pattern and drag down. All right, so for this problem, our principal balance, okay, so at the beginning, when we made no payments, our balance is the original amount of the loan, which is 600. All right, what is that going to go down by every time? All right, after I make one payment, it's going to go down by the principal that I've paid off, all right, which I don't know yet, okay, but it's going to be in this column here, so it's going to be H3. So I can set up a formula. It's going to equal the previous balance, okay, minus, okay, the principal that I'm going to pay. And then I could drag that formula down, and the spreadsheet matches it up. So it's always the principal from the previous one. If you look C4H4, the one above it. So it automatically does the recursive stuff for us. Okay, what do we know about this problem? We know our annual rate is 12%. Right, and so we'll just fill that down. It never changes. Okay, our monthly rate is going to be, again, we're going to do a little equation. We have to divide the annual by 12. So it's going to equal the annual rate divided by 12. Okay, so our monthly rate is 1%, and we'll fill that down. Okay, our growth factor, right, is just 1 plus the monthly rate. All right, so it's going to equal 1 plus the monthly rate. So our growth factor is 1.01 per month. Fill that down. All right, so our interest only, we could figure out, at least for this first month, how much interest was earned on the $600, right, at 12% annual or 1% that month, right? And so the interest that was earned will be just the principal amount left times that monthly rate, okay? So times the monthly rate. That first month, okay, before I make a payment, $6 of interest was earned on that loan. All right, and so that's what's going to happen. Now my principal only, I don't know how much I'm paying right now. All right, but I do know it's going to be the difference between the actual payment and the interest. Okay, so I know it's going to be that amount minus this amount. Again, I don't know that amount either, so I've got some unknowns here. All right, I did that wrong, so let me type that in. I actually hit the wrong thing there. I3 minus G3. So we're going to go ahead and fill that formula down as well. All right, this amount we don't know. All right, and so if we know this amount, then we'll know the principal amount. And then once we know the principal amount, we know what'll be left because we'll just subtract that from that. So we've got to figure out this first, and then we'll know that, and then we'll know what's left in the principal. So how do we figure this out? So, well, we could try guess and check, right? So, you know, at $600 for 6 months, right? If there was no interest, I would know it's $100. Right? And so I want to have this one because it's going to be the same every month. So I'm going to have that equal that. Okay. And so if we did that, Okay, and we have everything typed in. All right, what would be the principal balance left? We still owe $21.71. We want this to be 0. All right, so maybe if I pay the whole 106, because I earned 6%, maybe I have to pay 106 every month. Pay 106 every month, and I paid $15 too much. All right, so it's somewhere between 100 and 106. So let's go right in the middle. Pay 103 back. All right, now I still owe 325, so it needs to be a little bit more than 103. All right, so let's try 103.50 cents. Okay, now I still owe 18 cents. All right, so let's try, we got 6 months. Let's try 153, 103.53. Now we paid 1 cent too many. So it's a rounding thing right here. So this is going to be our principal and interest payment every month. If we paid 103.53 back, we would pay back our $600 loan in 6 months at 12%. Right? But we are not going to sit here and do guess and check, especially if it's a 30-year fixed rate on a house. Okay, we're not going to want to guess and check that. We want to be able to come up with a formula. So there is a pattern based on what we know. We know that the principal balance left, okay, it's going to be how much interest was earned. So that the 606 minus, okay, the principal. All right, so we need to come up with a formula for that. All right, so we're gonna try to explain that over here now. Okay, so if we say that P of 0 equals P, and so what does this stand for here? Okay, P is the principal left. Okay, so the principal left and the input is the payment number. All right, so the principal at 0 payments made is the original P, which was 600. We could see that clearly. All right, and so now if I make one payment, okay, what is the principal left after one payment? All right, so how do I figure that out? Well, it's going to be, okay, the previous amount, this is the recursive part, right? The previous P of 0, the previous balance left, times the growth factor, which in this case is 1.1. We're just going to call that I. Okay, let's call that I for now. Right? Minus the amount paid. Right? Will be the previous balance left. Right? So again, where did we get this amount from? Right? It was the month before times the gross, how much it grew. So what is the new balance at the end of the month? What did I pay? And that difference, right, is being what I'm going to be left with. But I know that P of 0 is just P. I'm just going to rewrite this as P I minus A. Okay, so then we keep going. What's P of 2 going to equal? Well, P of 2 is going to equal the previous amount, so the balance after one payment, times the growth factor, minus the amount. And what do we know that P of 1 equals? Well, P of 1 equals PI minus A. So I could just substitute that in. PI minus A times I minus A. Again, so I just, where that P of 1 was, I replaced it. Okay, so now what I need to do is I need to distribute this I. Okay, so we're still on P of 2 right now. Okay, the balance after two payments is going to be PI squared minus AI minus A. Notice this exponent matches the payment number, the input number. Okay, so if we do P of 3, P of 3 is going to be P of 2 times the growth factor minus the payment amount. And then again, I could just substitute this into here, right? So all I'm doing is I'm going to distribute I to this up here, all right? So I'm going to save myself a step of rewriting. I'm going to distribute, so it's pi cubed minus ai squared minus ai minus a. All right, and so there's a pattern there again. So on the pi, right, the I is cubed as to that payment number, that input amount, and then the amounts are, okay, are going down. So it's 2, 1, 0. So it's 3, 2, 1, 0 on my exponents, right? So if I know I'm going to go all the way down to P of 6, right? Can I predict what P of 6 is going to be? P of 6 should be Pi to the 6th minus AI to the 5th minus AI to the 4th minus AI to the 3rd, right? Minus AI squared minus AI minus A. Right? So imagine if this was a 30-year loan where you have 360 payments to make, right? Would you want to do all this all the way down to 360? Right now, so we need to generalize this. All right, and so if I generalize this, okay, P of n, so n can be any number of payments, okay, it'll just be pi to the n, right, minus ai to the n minus 1, right, dot, 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 all the way down to a. All right, so now what I'm going to do is I'm going to use this generalization, okay, and I'm going to simplify this, right? Because if you notice, right, all these a's in here, I'm going to rewrite this. I'm going to factor out an a, right? So I'm going to go p of n equals, I can't do any, there's no a in this first one, so that stays the same, pi to the n. If I take out a negative a, so I take out a negative a, what's that leave me with? That leaves me with I to the n minus 1, right, plus I to the n minus 2, right, all the way down to 1, which is I to the 0. We're just going to write 1. Okay, and so this right here is the sum of a geometric series, which we learned in the first semester. So we'll have to do a little review on that. But I'm going to rewrite this with summation notation. I still have pi to the n minus a. I'm going to write this parenthesis in summation notation. All right, and so we're going to go from 1 to n, okay, of I to the n minus 1. All right, so, right, and then our example would be from 1 to 6, okay, of I to the n minus 1. Again, because we're adding up 6 things, 1, 2, 3, 4, 5, 6. We're adding up 6 things, right? So here we're adding up n things, right? And we're starting with the n minus 1 power. All right, and so because that's going to be, if I plug in 6, I need it to be 5, right? So there we go. All right, and so that's our formula, but we want to actually solve for a. All right, so what we know is that on the last payment, whatever it is, the nth payment, we know that that principal is going to be 0. We want that number to be 0. So I'm going to set this equal to 0. I'm going to go 0 equals, right, pi to the n. Let me erase this out of our way for right now. Minus a times the sum from 1 to n of I to the n minus 1. And I want to solve for a. I'm going to add this whole term to the other side. So I'm going to get a times the sum from 1 to n of I to the n minus 1 equals p, which was our original balance, times I to the n. Now I just divide both sides by the sum. Okay, so a equals p times I to the n over the sum from 1 to n of I to the n minus 1. Okay. And so since this is just the sum of a geometric series, we have a formula for that. So we may need to look it up. And the formula is I to the n minus 1 over I minus 1. All right, and since we're dividing by a fraction, that means we can multiply by the reciprocal. So I'm going to rewrite this as p I to the n times I minus 1 over I to the n minus 1. And this is our generic formula. Okay, so we can figure out any loan with this formula. So let's go back and let's do that. Okay, instead of guessing numbers right here, okay, let's go back and type in that formula. Okay, so out in front is pi to the n. So you could just type in 600 for p or click on the cell since it's there, times I, which is the growth factor, okay, raised to the, and again, 6. All right, in this case, and it's 6, you could type that in, or you could have just clicked on that cell. All right, and so that's what's in front, and we're going to multiply that, okay, by a fraction. Set up that fraction. On top, well, it's in top, we'll put in parentheses, which is I minus 1. So F3 minus 1, that's on top. On bottom, okay, we're going to have I to the n, okay, which I'm going to want to put that in its own parentheses. I raised to the nth, which is just 6, minus 1. And then we have our payment, which is what we had calculated earlier at 103.53 when we were doing guess and check. All right, and automatically fills in. All right, after our 6th payment, we have 0 balance, and that's so that formula is going to do that, and then it calculates the principal payment that we made every time, and that's what we end up subtracting from the previous balance. So all this work right here, we're going to recognize something that we learned early on in the school year, is that it's the sum of a geometric series, and we could use a formula to help us figure that out.